All right, guys, good morning. Sorry, I didn't have my book lined up right before the video started. So, let's see here. Try not to get my face in the corner. There we go. Okay, so we're going to go ahead and start Module 12, and I need you to go ahead and make sure you have your math spiral out. Make sure you've put your page number over here, and today's date is the 14th. Yeah, it's April 14th, y'all. It's been over a month since we've all been together. That's just weird. I don't like that. Anyway, so we're going to talk about a couple of vocabulary words. We're going to kind of make some notes about the difference between expressions versus equations. I know we've already talked about it, but I want to kind of just add a little bit more information. And then we'll work a few examples of what this first part is. Today's math lesson I broke into 3 short videos just to try to keep it like going a little bit faster. And then you can get up and stretch in between. Today's lesson is not that difficult, but it's setting the foundation for Thursdays and next week's, which gets a little bit more tricky. Okay, so equation. We already know, we've talked about an equation. You guys usually will say an equation has an equal sign. Yes, but we're going to put a mathematical definition, of course, right? So we're going to say it is a mathematical. So it feels like we're more in class. Oh, that is a terrible C-A-L. My bad. I started writing in cursive. Should not have done that. Okay, I will go back to printing. Statement. Okay, a mathematical statement that 2 expressions are equal. So we've been talking about expressions not having an equal sign, but if there is an equal sign, then we're saying the expression on this side of the equal sign is equal to the expression on the other side of the equal sign. Remember the balance that we had in class before the break where, we had to make sure both sides were balanced. Okay, so whatever's on this side is one expression, whatever on the other side is the other expression, and we're saying they're equal, then it becomes an equation. Okay, and then solution, well, I'm going to give you kind of a technical definition for solution. Oh, I'm sorry. Also for equations, we're going to put a little star over here. May or may not contain a variable. Okay. What's a variable? Any of those letters. A, B, C, X, Y, Z, T, R, S, whatever. We've used every letter. F, R, I've already said R, whatever. We've used a lot of them. So any of those letters are the variables. So an equation doesn't have to have a variable. 2 + 3 = 5 is an equation. Doesn't have a variable, okay? It's got one side is equal to the other side, right? Okay, so then a solution. So if an equation has a variable, okay, so that's kind of, this is where solutions come in. If an equation has a variable, the solution is the value or number, but value, if you want to put number in parentheses to help you, but we're fancy now, we use the word value for number, is the value of the variable, okay, that makes the equation true. Makes the, equation true. Okay, don't y'all feel like we're in class? This is pretty much what we'd be doing in class. Okay, so an example here would be if I had x plus 3 = 5, okay, I have a equation and it does have a variable. So the solution, for this one, x, the only solution could be is that x is 2 because there's usually only one solution, right? Usually, unless we get into inequalities, but we might not get to inequalities. We're kind of running out of days. And when you get to inequalities next year, there's multiple solutions. But with an equation like this, there's one solution. X has to be 2 to make the equation true. So whatever the value of this variable is, that will make this equation true, that's considered the solution. So you're going to see, have questions where like, is 5 a solution for this expression? And you're going to go, what are they asking? They just want to know if you put 5 in the place of the variable, will it solve the equation? Will the equation be equal on both sides? So the other thing I want you to add here is expression versus equation. So we talked about expression, but I want to add, because I never mentioned this before, is that an expression represents a single value. So think about that. An expression represents a single value. If I just had 4 plus 5, no equal sign, it's an expression. And what does it represent? 9. It represents a single value. Even if it was x plus 3, it represents one value. Once I know what x is, I know what the value of it is, but it's just one value, right? Versus an equation. Oh, my dogs are barking, sorry. Almost yelled. I don't want to yell. Represents a relationship, this is important, or this is the difference between two values. So if I have 4 plus 5, that's my expression. It just represents one value. But if I have 4 plus 5 is equal to 8 plus 1, that would be an equation, okay? Or I just put a 9 at the end. It could just be 4 plus 5 equals 9, okay? But it's comparing two values. This expression is equal to this expression, or this technically value, the value of 4 plus 5, 9, is equal to this value, 9. So in an equation, you're comparing to, this is really where the balance comes in that we were playing with before the break. Okay, both sides have to, they represent a value that's equal to each other, whereas an expression is just one value. Okay, so just a couple of examples to work here about, because up here I said, well, if I had x plus 3 equals 5, then the only solution would be 2. Okay, so sometimes you're going to be given a solution and you're going to be asked, is it a solution to the problem? So let's write a couple of these down. Let's do a couple of examples. If I have x plus 9 equals 15, and you're asked, is x equals 6 a solution? Okay, so you'll see it written a couple of different ways. You might see it written like this. If I substitute 6 in for the x plus 9, is it equal to 15? Because is 6 going to be, if I put 6 in for the x, is that going to be a solution to make this equation equal? And then you go ahead and add 6 plus 9 and you go, okay, this is correct. This is correct. They are both equal. So those are, this is a solution. X equals 6 is a solution for this equation. Okay, so that's one example. Okay, let's try another example. What if I have y over 4 is equal to negative 32? And I want to know, is y equal negative 8 a solution? Okay, so I've got to substitute in my negative 8 over here. I got to go negative 8 over 4. Is it equal to negative 32? I'm running out of space, my bad. So I'm going to continue over here. Sorry about that. So now I have to solve this side. I got to figure out what the value is. Negative 8 divided by 4, and negative divided by a positive is a negative. So this side is negative 2. This side is 32. Oh, sorry, negative 32. Are they equal? No. So this one we would say yes, x equals 6 is a solution. This over here, we would say this one yes, this one no. Y equals negative 8 is not a solution. Okay, so you're going to be asked different things like that. So what I'd like you to do is I'm going to pause the video, or I'm going to stop this video in a second. But before I stop it, I want you guys to open up you should have your books handy. I want you to go to page 322. Okay, top of page 322. That's going to be the next video. And I want you to work these three, your turn. Again, it's the top of page 322. Okay, and work those. And then we're going to stop the video and we'll come back and look at these and go into part 2. All right, see you in a second. Bye.